Okay, well, thanks everyone for coming. It's got a good crowd here, so that's a good thing. And okay, we're starting. So we're going to talk today about Bazel migration patterns. Basically, we want to talk about how to prove business value with a small investment. A lot of companies do migrations now, so I think this is probably important to address. My name is Greg Magolan. I am co-founder of Aspect Development, and we, as far as we know, we're maybe the first Bazel consulting company. We help teams that are small to large enterprises to migrate and plan their Bazel migrations. And we also worked on open source project migrations like the Angular project. Oh, Alex, you go.
Yeah, hi, and I'm Alex. I work at Google. And Greg and I are the maintainers of Rules Node.js, although that's not what we're talking about today. Thank you. Right, so how to migrate to Bazel. So this talk is based on a lot of experiences that we've all heard here at BazelCon over the years, and from Greg and my interactions with enterprises who are adopting the things that we've worked on. And the things we want to talk about is how do you sequence the work, pick the right things to do when, in what order, while you're keeping your business running and keeping the partnership strong between engineering and management. We're assuming in this talk that you've decided to do a Bazel migration, so we're not going to talk about what are the advantages, why should you do it. And this is not about any particular language, so there's been a lot of talks about how to migrate a particular, like from Maven. We're not going to talk about those things. We're going to try to keep it very general. And this is not a very technical talk. We will show some code slides, but it's really about how like a tech lead should approach this migration. So let's start with how not to approach it. And I think this is the way I would like to start a migration. I'm as an engineer, and I look at Bazel and I make a claim like, well, it's better. I mean, it's correct and it's hermetic and it's reproducible, and those are properties our build should have. So we should just do it. So let me get my laptop and start coding. Or after we're finished with the migration, I saw these talks at BazelCon and it's going to be 90% faster. So I'm going to get my laptop and start coding. It's the fun part. Or our current build system is just bad. Like I'm just tired of dealing with it. I just want to replace it. So those are all perfectly valid motivations for you to have as an engineer, but they're not good justifications, I think, for doing a migration project. Because infrastructure teams are always very underfunded. I know I feel this. I imagine a lot of infrastructure teams do. You look at the number of engineers that you're supporting and the sort of like business value they provide, and you feel like you should have twice as many people on your team. Just not how it works. Migration is probably going to take a long time. We'll talk a little bit more about sort of what to expect there. But very importantly, this is a business critical service. You have to have engineers able to write code and run the tests and keep commits landing. And you can't have downtime in that system. And so the build and test is like critical, right? And so when the business looks at at build and test as a business critical service, they're not going to let you monkey with it in ways that hurt the velocity of your company. And so funding this kind of migration effort is hard, and your boss will tell you to stop. And so this talk is really about how to keep your boss from telling you to stop.
Thanks, Alex. So let's start with the right approaches to do this. I think the first thing you gotta do is plan. The discovery phase in a large Bazel migration is critical. That's really answering the questions of why are you doing it, when are you doing it, and how are you doing it. This is where you wanna de-risk before you start your main effort. Some things you do at this stage is you would do an itinerary of your current build system, identify your biggest productivity drains and costs, which is where you're gonna get the most value from this migration. You wanna find the low-hanging fruit, maybe the steps that are easiest that you can get done really quickly and easily. And another thing you can do at this point is identify some missing integration tests that you have in your system. Bazel makes it easier if you're working between teams and everyone's building with Bazel to run these integration tests. So maybe there's some coverage you can add that would add a lot of value to your development workflow. You also, at this point, it's important to size the effort. Typically, we see that migrations are long-term, greater than 12 months, greater than 1.5 engineers. BMW, I don't know if you guys saw the talk earlier, but they had a great example where they did a really strong discovery phase. They put, I think, 5 or 6 engineers on for 4 months, figure out all of the complicated bits of their migration. And when they were sure that they could do it, then they swarmed everybody. They put 100 people on for a month, which they got theirs done in about 5 months with that strategy. Yeah. So the last thing I want to do is, at this point, if you know you're going to be in for a long-term migration, is establish milestones along the way that make business sense. This is important because you might want to halt your migration partway if maybe the next step doesn't make business sense at that point, or if you just want to reallocate resources. So if you do stop halfway, you're still in a happy place. You're not killing your development team. So what are the right incremental steps that make business sense? I would say that these fall into 3 categories. First, you want to take steps to maximize and expedite the benefits of this migration, which means really find out what's going to give you the value early and do those steps first. That's a good way to convince your leadership and your devs about what you're doing. Second category, I would say, is you take steps to mitigate and delay risks, which this is probably frequently overlooked with people. They just get in and start coding away. But if you plan ahead a little bit and you identify those risks early, then you can take action to mitigate those risky steps. And the third category is you want to try and minimize and defer the costs of this migration, which a couple of examples there is training costs. If you change your entire development workflow on day one, that's going to incur huge costs. So you might want to wait for, if you are going to do that, wait later on, or just try and keep your development workflow the same. Also, you might want to defer the complex parts of your build system for later, because that's going to incur the cost of having to relearn your entire legacy system.
So, apologies to mathematicians in the room who would like a rigorous treatment of the gradient ascent problem. This is not that, but I think it's a really useful mental model for me in thinking about like why we're taking this approach. So, gradient ascent means you want to get to the top of one of the hills, and you don't have any idea where you are or which direction the top of the hill is. All you can tell is which direction is uphill from where you are right now. And so this is, there's algorithms for this where you take a small step and then you recalculate which way is uphill and you keep going. You get to the top of some hill. And I think this is a lot like the migration steps, because if you imagine here that the height of the hill is this sort of benefit ratio to the risks and costs that Greg is talking about, then as you go uphill, then things are improving for your business, your boss is getting happier. Going downhill is making things worse. And the longer you stay downhill, the more your business is being affected by the migration that you're working on. And so even though in gradient ascent you don't get to the global maximum, I think that's actually modeling the business reality, which is that you have to keep improving the build. You can't make it worse, at least not for a very long time. And so if you think you can get downhill and then back up really quickly before it impacts the business, maybe within one release cycle, then maybe that's possible. But I think if you get stuck down in one of these valleys, that's when you've totally gone off course. And there's I think maybe we've all had the experience of being like in that bad state for too long, and like we're like, hey, no, we're going to get back to the good state, I promise. And you just it's really hard to defend yourself when you're in that position. Okay, so what we're going to do next, we're going to go through benefits and then risks and then costs, and we're going to try to enumerate them. This is not the complete list of these things. These are some that we've come up with, and I think it's important in your organization to think about what things you see as being benefits, risks, and costs. So let's step through some of them that we've thought of. And in particular, like Greg said, we want to get the benefits sooner. We want to make the benefits bigger. So to expedite the benefit of catch bugs sooner, we all know that one of the advantages of using Bazel is that it can do integration testing, because it can build all of your code in multiple languages, and so you can write an integration test that's testing it head, your front end, your back end, everything together. And so if you add some of those integration tests first, then you can get the benefit of catching those bugs during your migration project. And to maximize the benefit from this, it's really more like proving the value of your migration. One thing you can do is to actually catch a critical bug. So this is like data loss, privacy, revenue, impact. I know Google takes these bugs very seriously. And if you catch this bug because you added an integration test that Bazel enabled, that's a great way to justify why you're working on this project. Similarly, there may have been past bugs that were not caught, but you can claim with some confidence that if you had the new integration tests that Bazel let you add, then you would have caught those bugs. And so you can look through your postmortems for action items and say, okay, we're doing this project because we had this postmortem and the action item said we needed to have these kind of tests, and Bazel lets us write them. Next benefit, faster CI turnaround. I think this is one of the numbers that we most frequently see. on the main stage of BazelCon is how much faster people's CI can be. Obviously, remote cache and execution is one of the main drivers of those benefits, so you should set those up pretty early so that you aren't running in a state where you say, Bazel is great, the reason we don't see CI numbers yet is that we haven't wired this up, because you'll get sort of the wrong first impression from your users if your CI isn't fast from the beginning. And then to maximize this, again, this is maximizing really your sales pitch or your defending the project. Make sure you have the before and after numbers. Make sure that they're comparable. This came up in the Wix talk yesterday. Understand what the benefit is from switching over your CI. Faster local development obviously is related. One thing you can do to maximize this is just to learn more about flags that Bazel has. Disk cache, I didn't know about for the longest time, and then some people on the Angular team said, hey, like this allows us to keep our artifacts when we switch branches. You should know those things, and make sure that in one way or another you're spreading that knowledge to developers on your team, so that it's not just little pockets of fast builds among everybody else being slow. The developers should be able to read from the remote cache. In a lot of setups I've seen, people don't trust developers to write to the remote cache because, of course, you can make a change locally that causes a non-hermeticity, and then you can poison the cache. And also, if you can, try to collect profiles from the builds out in the wild so that you know whether developers are actually having faster builds or not. This is something Greg and I are actually working on right now for the Angular team. Monorepo is something is closely affiliated with Bazel. Bazel doesn't require that you be on a monorepo. Of course, your workspace can have local repository pointing to other things. But Bazel does make it possible to do monorepo in the sense that it's computationally feasible now to say, I just run the test every time there's a change because I'm only going to run the affected ones. And so it's kind of hard to do monorepo without a build tool like Bazel. So I think monorepo is a long-term thing. The way you can expedite this, in my mind, is simply to prevent the next new repo from being created so that your problem's not getting worse. That's a lot easier than moving code that you already have. And then to maximize this one, since it's not tied directly with Bazel, it's not that you can do something in Bazel to make your monorepo better necessarily, but you're going to have to explain the benefits of monorepo to your organization, and I don't think that your Bazel build by itself is going to do that for you. And the last one is about the developer experience that your engineers have. So your current build might be a bunch of spaghetti and only a few people know how to edit it. And so if you're doing a programming task that requires modifying the build, then you're very sad and it's hard. The way I've heard this described in BazelCon is democratize the build. So everybody should be empowered to edit build files. You should do it whatever mechanism your company has to make engineers feel empowered to sort of like, you own these, like the stuff in here is your business. It's not somebody else is supposed to fix it for you. And obviously, the way to get the most benefit here is to find the parts of your legacy build that you are both touching often and that are difficult to change, so they're costing you the most time, and try to remove those first. So I'll hand it off to Greg to talk about risks.
Thanks, Alex. So let's talk about the steps you need to take to minimize your risks and what pitfalls and roadblocks you'll find along the way on your migration. So these are equally, if not more important than the benefits, because these are the things that you'll run into that will completely derail your project, frustrate your developers, and yeah, you've probably all been there. So one of the risks you might run into is you depend on an ecosystem with very pooled Bazel support. For example, Ruby, Nix, or maybe you're on .NET Framework. You can delay these risks by planning to migrate these parts of your build later. Or if you do need to migrate them right away, you can mitigate the risk by, you might be able to commit resources to these rules. For example, Coinbase is supporting Rules Ruby, and Wix is supporting Rules Scala, and that's worked really well for them. They've also become Bazel evangelists. Or you might also do some pre-factoring, which means that maybe you've wanted to move away for a tool that's not supported well on Bazel, and you can do that before your migration, so your migration is a lot easier. Another risk is you depend on rules with poor Windows support. So some rule sets have bugs that are Windows specific, or maybe just have poor support in general. Again, you could delay these migration steps. You could possibly migrate your build on CI first and leave your local development experience on Windows if your CI is Linux. If you do need to migrate your Windows builds right away, you can commit resources to resolving these issues. They're sometimes trivial, like a path issue on Windows rules, which I've worked on. One thing that's key is if you turn on file symlinks on Windows, by default, Windows only has junction symlinks, and Bazel will work a lot better with files and links, and some people just don't know that. That's a pretty trivial thing. Or you can have your Windows and Mac devs build on Docker. That's another option if that works for you. Another risk is your project has some unique property that doesn't work with Bazel. So to mitigate this, you might want to do a prototype first. B&W did a lot of prototyping on their build as they were doing that 4-month discovery. Before you start migration, that will prove the feasibility of it. You might get into the situation where you do have to write custom rules, which is great. It's actually quite idiomatic to be writing StyleArc, and it's nice to have someone on your team that knows Bazel that much. You might get pushback from the leaders in your organization, and to mitigate this, I think the key is to really prove the value ahead of time. That's what the leaders in your org want to hear so that you can start your migration. You can point to success stories in your community that may apply to you. There's a lot of great examples out there and talks and other conferences. You want to, this is where discovery comes in again, you want to identify the biggest productivity drains and costs early on so that you could prove what the value is going to be and show how you can solve these first. And you can also identify just the low-hanging fruit. What are the easy steps in your migration that you could do? Maybe get remote cache on early, maybe get remote execution going right away. If that doesn't work, you could commit to a small team to do a longer discovery phase, which is less expensive than going for a full-blown migration, and you want to prove the feasibility before you start the full-blown project. On the flip side, you might also get pushback from your developers. With Bazel, it's pretty easy to make your dev experience worse if you aren't careful. You can do it unintentionally. Wix initially sped up CI, like we heard from Orb, but their dev experience decreased, but then they turned around and they really focused on the dev experience, which worked great for them. To mitigate this, you can fit Bazel into your existing workflows, have a glue layer. So if your developers are typing npm test, you could have them keep typing npm test, and that would work just the same for them. Try and make it transparent. You could also start with the CI, as I mentioned earlier, and you can keep parallel build systems for a while so that developers can flip back and forth if they're having frustrations with the Bazel build system. And I think it's good to plan to turn on remote cache and execution early for local development so the devs can actually see an upgrade in their experience when they switch to Bazel. You could also introduce a bug with Bazel. It might be that because your build's changed, there's a difference in your binary artifact. To mitigate this, you want to change as little as possible. So if you're already changing to Bazel, don't change your toolchain. Try and have Bazel call your existing build with all the same configuration and settings that you have. Don't switch from Webpack to Rollup, for example. If you, I don't know if you guys, or if you saw the SpaceX talk 2 years ago, but that was an extreme example where they actually, they're shipping these builds on Rocket, so they did a bitwise comparison to make sure along the way that every single configuration flag in their compiler was the same and every single bit in the final artifact was the same before they finally switched their build. They did no major restructuring. They did not get bogged down in improvements. Their goal was just to have bitwise parity. Now, if you do that, you probably have to prepare to relearn the details of your existing system quite well so you can reproduce it. You might have 2.5 or 3 engineers working on this on a time. The Angular team is a less extreme example of this. When they upgraded to Bazel, they wanted to reproduce their package format, and they had their Bazel build and their Gulp build running at the same time, and they had a comparison script, and they checked the results. If the difference was the same, they ran their integration test, and then they flipped the switch at that point. As an aside on SpaceX, I'm actually very excited to see the first Bazel astronaut go to space next year.
Just like we had the first Bazel car coming up in a couple of years from BMW, right?
So this is actually a shot of the Angular package JSON during the migration. So you can see there's a Bazel step and a Gulp step, and they had scripts to compare, which is how they got to the point where they're satisfied that they could flip over. Another problem is migration might just be hard, and your team does not have the expertise necessary to do it. You could do the easy steps first to gain experience. That's one way to go, and as your team gets more comfortable with the migration, you can move on to the more complex ones. Or you could get help. There's a Bazel experts page, and you can go to Slack and go to #jobs at Slack, and someone will pick up the phone.
Okay, so our last category of things to enumerate is costs. There are fewer of these. So the first cost is retraining your engineers. this is a cost you will incur. We're not saying that training won't be necessary. Bazel is going to be a leaky abstraction. Engineers on your team are going to see a failed CI with a bunch of Bazel stuff in it, and they're going to know that it's there no matter what you do. But you can make this a lot. You can reduce this a lot, I think. So one, as Greg mentioned, we want to try to keep things the same, and that includes the developer's interface to the build system. As much as possible, we want to keep it the same. So an example here, I got to go visit Capital One. They're working on migrating iOS development, and the iOS developers are used to being in Xcode, and so they spent some time with Tulsi, which is a project to generate your Xcode configuration from Bazel, and they're working through some improvements there to make the Xcode development experience not degraded by the fact that Bazel is also present. The other thing I think is useful is that as you develop those early experts, as Greg said, try to make there be a path, like an escalation path within your org, so that everyone who's having trouble knows that these are the experts who already know Bazel. I mean, maybe this is kind of obvious, but in some organizations you don't have that kind of transparency. And then those people can provide the training on demand, because I know I personally offered a 4-hour training to the Angular team about how to do Bazel, and their eyes glazed over after the first 20 minutes. And then we needed to keep giving them more on-demand training as we went, because it was weeks or months later that they encountered a problem and just hadn't had a chance to sort of use the training that they had gotten yet. So retrain along the way, or just hire the training people to come back every month. Okay, another cost is that you have to create a lot of Bazel configuration. And I know this is a cost I've heard from a lot of enterprises that keep holding them back from wanting to do Bazel. So the first thing I think is kind of obvious unless you come from a Google background, which is we don't need to have every single directory be its own Bazel package. And so I think it's a useful mechanism to start with to just have one big build with glob ***. I know glob is naughty. But this is a good way to defer that cost, and then you can split them up later, and we'll talk about that more in a little bit. To reduce this cost, obviously one thing is to have some tooling that generates build files for you. I know a bunch of us have sort of thought about how this would look. I think it's still not in a great state across the Bazel ecosystem, but Gazelle is pretty great, and it does have support to extend it to handle more languages. So we've been talking about a couple of languages we might want to contribute there. Your organization could commit some resources to do that. You can also use macros and maybe custom rules, but I think macros mostly does it, to reduce the boilerplate. So the build file should contain bare facts, and I got this bare facts from Alan Donovan, who's one of the original authors of Bazel. And it means that you should just list the sources, the dependencies, and not what to do or any of sort of the connection goop in your build. If that starts to leak into your build file, then your build file is too long. So we have an example here. I think it might be a little small in the back, but this is a file in the Angular repo, and we always check into tools/defaults.bzl. And what we do here is we load the original TS library, and then we override it with a macro of the same name. That's important. We want to follow the macro style guide so that in your build files, it still looks like a TS library. But what we do is we say, OK, well, there's some deps. So we always want TS-lib to be a dep. And then if it's a test, we add some common test deps. And then we set some defaults, like the TS config points to our default one. So this is a great way. Number one, it means that the build files across your repo are a lot shorter because all your load statements can come from this one place. So you just load defaults.bazel, all the things you need. And it means that in the future, if you do need to make a repo-wide change to one of the rules, you don't need to go everywhere and do it. You can just do it in this one spot. And of course, it means that that it's just easier for your developers not to have to type this stuff. And so it's often the case that this is the place that you come and make an edit to change your build across the repo. So another problem, another cost you'll find, this is also from the SpaceX talk, is that they had to discover all of the things that they had put into their old build. And it did all of these surprising things. I mean, of course it did, because most legacy build systems didn't constrain you in any way, and so you could just write whatever program and do whatever thing, and it was often one-off, and there wasn't sort of a consistent way to manage the build. So you will have to go find these things. You can defer this cost, obviously, by avoiding those unique snowflake corners of your build and start with something that is standard and turnkey, and you kind of know how to mechanically migrate like a Maven build. And the last cost is that during the migration, you're going to have some added complexity. This one is real. The only way to avoid this is to not have an intermediate state at all, which we'll talk about in a second. So assuming that you're going to have this intermediate state, the best way to reduce this, I think, is to keep it simple, stupid. Make your Bazel build really simple. don't do what we did, which is that we started from sort of the Google internal mentality, and we brought over a lot of the complexity of that system into Rules Node.js. And I think maybe other rule sets have done this, maybe authors have done this. You often don't need the sort of enterprise grade things in there at the beginning of your migration, and if you take on the complexity early, then that's going to hurt you a lot. So just like, I mean, basic software engineering principle, but try to avoid the complexity, avoid writing custom rules if you can. General is just fine. I think general might be the best Bazel rule of all. Not getting a nod from Dimitri. Or if you do need to write rules, keep them really simple. So one thing we learned is that we had some places where we were using fancy providers to propagate information through the dependency graph. And if we had just used default info, things get a lot simpler. Rules become a lot more obvious how to compose them in a new way. So I just called you all stupid. I'm sorry. OK, so now what we want to try to do, we've enumerated the benefits, costs, and risks. And so we want to try to distill these. We want to use those as a rubric for evaluating different patterns that you can use to transform from your legacy build, represented here by a cute sauropod, transforming it to Bazel. This is based on techniques that we've seen from across the industry. We're not inventing anything new here. We're just trying to sort of group them together and give them names and put cute dinosaurs on them. Some of these patterns might apply at your org, but some of them may not, so your mileage may vary. Certainly, these are also not going to be mutually exclusive, and Greg will talk about how to compose them. And so what we're going to show here are diagrams, and I will show the first one. I just want to point out that the arrows here between the dinosaurs is not necessarily like an execution graph. It's not like I just run dinosaur.sh at the top, and then all of this is automatic. It may be that these are sort of more conceptual arrows, and like first the developer has to go do this, then check it into a repo, then fetch the new artifact, then put it into this other repo. So think about this as being this sort of high-level flow of your build if you were like an armchair architect and this is what you did. So Big Bang is our first migration pattern. This is really simple. You have a before, and then you make a commit, and then ta-da, they're all Bazels. This is great. I mean, this lowers your costs a lot. Like I talked about the added complexity during the migration. There's no during the migration. It's just before and after. But it's also, I think, not viable for most enterprises. Like you would do this for your toy application. Like you have a demo repo. You would just do this. So this only works if you have a development team that's really enthusiastic, and so you can get a lot of people to come work on it at the same time. Like I said before with this gradient ascent, I think you need to fit this within some development lifecycle at your company, probably like within a release, because it's very disruptive. And if you can't land this all in one commit, then the build and test is broken in the middle and people can't get work done. So it requires a lot of careful planning. I don't have an example of a Big Bang Bazel migration, but there is this fantastic blog post from Lucidchart about how they migrated from JavaScript to TypeScript. And it's a very similar sort of traverse the graph, figure out what you can migrate. And so I recommend reading this if you think that you want to try to do Big Bang. This blog post will impress and scare you. And then the next pattern I'm going to talk about before I hand it back to Greg is parallel builds. So in this model, we have our tree of dinosaurs, and it's mirrored into a tree of Bazels. We keep both of these things working. We have a CI for both of them, like Wix talked about. They had the old CI, the new CI. And we're in this state for some period of time during the transition. So first we're building up the tree of Bazels, and then later we can tear down the tree of dinosaurs. So I'm going to be brave here, and I'm going to use Google as the case study for this one. And I've been at Google for like 11 years, so this is even before my time. So 13 years ago, you probably all heard Google 3. So yes, there was a Google 2. And part of that migration was to introduce these files called build. And they were configuring the legacy build system at the time. So when we moved to Bazel, it was really, we already had these build files, and so we did a fix-it, which is Google's way of getting a bunch of engineers to kind of swarm onto a problem by giving them prizes like T-shirts. Obviously, it doesn't work anymore, but long ago, people didn't have enough T-shirts. So this was called the Revolution. You can read about it on Mike Bland's blog. It's a very interesting, history of the software industry. And if you're into Bazel, it's just interesting to see where it came from. I'm just trying to represent what I learned from Alan and Mike and a couple of other early engineers on the project. So what we did, we took some ugly compromises. We retained features in the build language that we don't like because we had to keep the migration small enough, right? We couldn't change more than one thing at a time. We set up remote execution pretty early, thanks to Ambrose, who invented this in his 20% time. And that was really critical to getting all of the tests migrated onto Bazel, and sort of like I said, like having the benefit come in early was an important migration to like get this benefit earlier. So how do we feel about the Bazel migration? It was just finishing when I started. So the legacy build system, it took us about 18 months to completely tear it down. I think a lot of that was long tail. So it was really like most of the work was much faster, and we felt like that was a short timeline. But even so, the management at the time, different management than now, was really straining their patience in terms of how long this migration could keep happening. So it wasn't obvious that we were able to accomplish this. Developers felt the pain because they had to keep both of the build tools working, right? And this is during the migration, you have two build systems that both need to work. And that's true even though we had the same configuration files for both of those tools. So only about a quarter of the build files in the Google 3 repo actually needed to be touched to migrate from the legacy build to Bazel. And even so, it was hard for engineers. So imagine, in your situation, you probably are going to have two separate configs. And so that's even more effort for engineers. And in the Wix talk, there was a lot of discussion about how the IDEs were kind of broken by Bazel. We totally did that too. Don't have time to go into details on it, but that's how we did it. So yeah, we did parallel builds. So I'll hand it back to Greg.
Thanks, Alex. So the third pattern that we're going to talk about is called deploy artifacts first. And in this pattern, you're going to leave your test alone initially. You're going to find a binary that you produce, and you're going to migrate that first. This is a good pattern to use if you find that your packages are actually the things slowing your developers down. You can build your binaries, and then you can parallelize that and get some good value out of it right away. This is one of those patterns like Angular and SpaceX where you might want to compare the results of the Bazel build to your legacy build initially. And you might also want to take the outputs of those binaries and run them into your integration tests with your old legacy builds to make sure your integration still pass. So after your binaries are passed over to Bazel and everyone's happy, then you can start migrating your tests at that point and get more value and parallelization for the rest of your build. So the case study on this is back to Angular. And when Angular migrated to Bazel, they wanted to standardize their distribution format called Angular package format. In the old build, the legacy shell script, it was clunky, it was unmaintainable, it was not portable. It was the long pull for them, building packages on CI, so that was a natural first fit. And they were able to parallelize this using remote cache and execution and really get a good value right away. And I don't know remember the CI speed upgrade on them, but it was pretty good. It went down from like 30 minutes to something, maybe 5 initially. And the other benefit they had was the new portable rule that they had to do this binary migration called ngpackage. They could use in other repos, so Angular Material, NGRX, and those repos started to use it right away. On the flip side, you may want to parallelize your tests first. So you leave your binaries alone and you target your tests. A lot of CI builds and local development times have a lot of tests they can't parallelize, and that's really a pain for developers. And so if you get your tests over to the Bazel early in your migration, then you can use parallel and remote strategies in CI and for local devs. And you can also shard your tests. So you don't necessarily have to break up. If you have large tests in your repository, you don't necessarily have to break them up right away. You could shard them, and then it saves you on making configuration. You can do that. So the case study for this came from Everest Microsystems. So the first step was to migrate tests for shared libraries, and they set up AWS S3 cache right away. And their local devs got a read-only access to this cache, so they had a speed up for the development experience right away. They didn't have to run every test every single time. And Everest also measured their build to see that they were getting those cache hits so they could show that it was working the way they intended. Alex.
Okay. So our next pattern we call inside out. It's pretty simple. You just start from some inner node in your graph. You migrate that all by itself, just this little tiny island of Bazel in the sea of dinosaurs. And then the island gets bigger over time, usually following some dependency edge in the sort of, again, the logical graph. Because now these two nodes are able to sort of share cache hits with each other. Or I should say, one of them gets cache hits from the other. And so this way you have a little island of goodness that can sort of expand over time. So it's obvious how this one can grow over a really long migration. So how to do this, we talked to Improbable. And one of the things they did during their migration, they had a protocol buffer to TypeScript code generator. that was kind of slow, needed to run in every single build, and it had the advantage that the protocol buffer, I think, was not changed that often, and so you could always get a cache hit for this. And so even though it seems like overkill to download a tool like Bazel and install it and set it up just so that you can like cache the results of this one thing, like clearly you could write some script to do that. This is already, this is a very small step in the right direction that allows you to get Bazel in place and have it providing value, and then grow that more slowly over time. The flip side of that one we call outside in. So in this one, you're going to start with Bazel sort of orchestrating the existing legacy build. And over time, you can then imagine that, again, this one will grow slowly over time. You will start to have the things that Bazel is calling can be migrated one at a time from the legacy build system to be their own Bazel steps. Our case study here comes from Lyft. So they use a tool called Envoy, which does some fancy network stuff. Envoy itself uses CMake and Ninja as a Bazel action. And I put a pointer here to a spot where they do that. And so when Lyft wanted to have they have a mobile version of the Envoy library, and they want to migrate their iOS and Android builds to Bazel, it's really convenient to not have to go back and tamper with this part of Envoy. They did report that this introduced a lot of complexity because they are now running these two build systems at the same time, but it also deferred a lot of cost from having to migrate these things. And then also the talk earlier today about BuildStream went into some of this about how you can sort of call the existing tooling from Bazel. And I think the speaker there mentioned rules 4 in CC, which I'll also point to here. This obviously is for C++. I think there are ways that you can do this, certainly in the JavaScript ecosystem that Greg and I work on. You can just call out to your existing tool as a big Bazel step.
Okay, so I'm going to talk about a pattern we called Coarsegrain first. And in this pattern, you start migrating with a small number of large global actions. So you're not necessarily looking to get incrementality from your build right away. You want to get as much of your build over to Bazel as possible. You could turn on remote cache, which you would get that benefit. You're not worried so much about breaking up your build at this point. You would do that next. And then as you do that, you would measure these global actions, see which of them are causing you the most pain, and start splitting those up into smaller pieces. So an example of this is the, where's that example? Okay. The Angular team did this when they did their package format. And they started by doing one TS library rule for an entire package, and then they would get all the packages of the Bazel and then start splitting it up from there. And when you do this, you also have to worry about cyclic dependencies too. So Bazel can't handle that between targets, which is one reason to just do a larger target one at a time. And in the real world, not all repositories are uniform. So you may have different sized dinosaurs. You may have some baby dinosaurs in there. You might even have a Stegosaurus, which is a very unusual build step that maybe Bazel can't run. Real repositories have a variety of tools for build, a variety of tools for test. They're building multiple applications and multiple teams. And you're probably going to use a variety of these techniques to migrate. The critical part here is the discovery step. You really want to identify what's in your legacy build system so you know which tools you need to convert. And you convert slowly. Maybe you start building the little Bazel pieces together into larger combinations. And then finally, your entire build will be Bazel. You might still have a Stegosaurus in there. So the case study for this, we talked to Kyle at Oasis Digital, and he started converting his repo little by little islands at a time. And as these islands of Bazel grew closer and they were adjacent, then he'd compose them into larger target groups. And finally, he put a top layer in to make his entire build converted over.
Okay, I think this is the last one. We're almost done. So for monorepo, again, this is not closely tied to Bazel. Bazel enables monorepo. But we've done a couple of these. The typical pattern we see is that the monorepo on the left starts off with a migration. And it has, at least uses the outside-in pattern. So like you have the top level is a Bazel target. And then it has a conceptual dependency on this other repo. So then the first thing you do is you migrate the other repo to Bazel, at least at the top. And then you add this dependency edge. And this can actually be two separate steps here. So the way we did this, I'll talk about it actually here on this slide. So we did this for Zone.js. This was a separate library that really belonged as part of Angular. We had some pain because we changed it and we didn't see that it was breaking Angular, so they wanted to be continuously integrated together. So the first thing is we migrated the Zone.js repo to Bazel. Then we moved the code to the Angular monorepo. But at that point, and actually still true today, that edge is not a source dependency edge, but it's a binary artifact dependency edge, because that's the easiest thing to do first. So there's still a publish step followed by a consume step, and then you change that edge to be a source dependency. And credit to Jali, who works at ThisDot, who did a lot of that migration work.
Okay, so we're almost through, and I'll just summarize what we talked about. To plan and execute a successful Bazel migration, you want to pick the right incremental steps early on to your discovery so you know what you're going to do. We've given you some general patterns to follow. They're not specific to any language. So you want to look at de-risking by choosing the right patterns and proving the value early ahead. And really, to go back to those 3 points, you want to maximize your benefits, you want to minimize your risks, and you want to minimize your costs as much as you can. So thank you for listening. And if any of you are planning a Bazel migration in the middle of a migration and you want to talk about specifics, then please find us after the talk, and we're happy to give you advice on your specific situation.
So we have time for maybe 2 quick questions. Next talk needs to start on time because people may be moving. Yes, over there. Did you hear that?
Yeah, I think you're talking about bare facts. I'm summarizing from a very short comment he left on the slides, but it's basically don't put stuff in the build file that doesn't have to go there. So like really only declare the sources and the dependencies, and the rest of the goop in your build shouldn't be there.
One more question? Going once? All right, thanks again. I'm sorry I left you out. I just thought this was Alex. I think like the thing, so my apologies. Great talk, by the way. I really enjoyed it.
Yeah, thank you.
Really nice.
The slides are not.